Thank you, Magnus and Anneli, for opening the event. Thanks for the great introduction. So, hi and welcome everyone from my side as well. My name is Rehan Chowdhury, and I will be your host during the course of the day. And actually, the first speaker that we have lined up today is a very interesting and inspiring speaker. Her name is Alice Steenland. She is the Chief Sustainability Officer at Dassault Systèmes. And she will talk about how virtual universes can help accelerate sustainable innovation. She will also talk about virtual twins and how this is actually the decade to deliver on the UN sustainability goals. So thanks again, and a warm welcome to Alice Steenland.
Well, thank you, Rehan, and thanks to everyone for being with us today. I'm so excited to be with you. I am the Chief Sustainability Officer of Dassault Systèmes. But in my former lives, I used to do a lot of work with the healthcare and pharmaceutical sector. So I am particularly happy to be with you today. What I think is interesting about folks who work in healthcare is that they have a very holistic view of also often how human organisms interact with environmental systems, and this real sort of systems thinking, the human body as a system and as a system within a broader system. So that has a lot to do with sustainability, which is the topic I'm here to talk to you about today. And the specific angle coming from Dassault Systèmes that I wanted to talk to you about is essentially how virtual twins interact with sustainability. So we hear a lot about sustainable tech, green tech, climate tech. There is a consensus, I would say, globally that the technology agenda is merging with the sustainability agenda. And that we will not be able to accomplish our sustainability goals without pretty significant advances in all forms of technology. And that probably the other side is true too, which is that tech has sort of a new purpose, I would say, also thinking about its own footprint and the way technology makes the world more sustainable, is sort of providing this kind of purpose for the industry, which is wonderful to see and is really motivating a lot of us working in this sector these days. So this specific form of technology is one that you hear much less about. So when we talk about sustainable tech and the intersection of those agendas, you hear very often about how, for example, blockchain is being used to build transparency in supply chains, how satellite data is helping us to capture deforestation, how IoT technologies and sensor technologies are helping us to catch and capture all sorts of emissions data in a way we never could before. So that is all very true. What you hear a little bit less about is what a virtual twin is and how it can revolutionize sustainability. And I am a big believer, and so is Dassault Systèmes, in this vision of what this technology can do. And I am very happy and honored to share it with you today. So I have a few slides to go through with you: virtual twins and sustainability. And this is a takeaway from a paper and some research we did with Accenture on this topic. And so I'm going to share some of those key takeaways with you today. So first of all, as many of you know, this is what we call the decade to deliver. So 2020 to 2030 is this period in which either we are able to collectively reduce our emissions by half, or we will fall into a scenario of essentially irreversible climate change and irreversible rise in temperatures beyond the 1.5 degree habitable threshold for humanity. So we have now less than 10 years to make really radical changes to our systems. And you can see that we're already hitting those planetary boundaries. So, at sea, you have nearly 90% of the world's marine fish stocks are fully exploited. We obviously, on climate, we need to be falling by about 8% a year, our emissions, in order to limit temperatures. As a point of reference, during the pandemic, emissions fell by 7%, and the entire economy globally had been shut down. So that gives you an idea of how important that effort is. Our food system, a third of the world's adequate food producing land has been lost, so we are losing the ability to feed ourselves. We are obviously impacting the Earth's animal population, massive biodiversity crisis. And of course, everything you hear about water. So we are running very quickly into a shortage of fresh water, and I would say too much salt water with sea level rise. So what's interesting about this period is not only is this the period of urgency, but this is the period where I think we all as citizens are starting to feel that urgency. We're starting to see the damage. We're starting to see the fact that our economic system is not sustainable, and we are going to have to change. So there are less than 10 years now left to achieve the UN Sustainable Development Goals, which we call the UN SDGs, and we are woefully off track. And I think the conclusion for businesses is to say that incremental change is really no longer an option. So I've been working in this field for 20 more so years. We have been making progress, but is the world, functioning at a sustainable level now? No. And that is sort of the urgency right now, is that we have to shift from these incremental, we are getting better, we are being more efficient, we are reducing our emissions, et cetera, to more radical changes in the way we design the economy. So virtual twins, why are they interesting from this perspective? And they are interesting because real disruption in technology is often completely impossible without virtual twins. So virtual twins are used to model complex systems. And so it can be a car or city or a human heart or human body. And they can model it and then simulate its functioning to a very, very high level of accuracy. So as an example, you can almost get your car and your airplane certified in a purely virtual universe, because not only can you show what you're building or what you're planning to build, but you can show how it will work in the real world, and you can test it against real world conditions and simulate its use to an extreme level of accuracy. And this technology, because of that, allows you to go from an idea. So before anything is built, you can do all of this. So you go from this idea into creation in an incredibly fast period of time. So you no longer have to crash hundreds of cars to prove that they're safe and build multiple versions of them to see if they work. You now do all of that experimentation and all of that innovation in a completely virtual universe. And then by the time you move into actual production mode, your design is already right. And what's interesting from a sustainability perspective is that now we can redefine what getting that design right means, to say we want to get it to be sustainable also. And that is why this technology has been used for some of the world's biggest sustainability breakthroughs. So 85% of the world's electric vehicles were designed using this technology. 75% of the world's wind power was designed using this technology. So any kind of major breakthrough where people say it is not possible to build that, you cannot build it, we have never heard of this, we don't know what it is, and we do not think it's possible. Well, you can make that possible in a virtual universe. You can build it from the molecular level all the way up to the simulation of its installation and its use. You can do that in a virtual universe and allow yourself to get the capital needed to build those really incredible breakthroughs. So this is the disruption that we need in the next 10 years. And this is the disruption that virtual twins are particularly well designed to deliver. So this is another look at virtual twins, about how sort of ubiquitous they are, how many applications they can be used. So for example, you have the power supply systems with 14% of global emissions coming from energy reductions in that loop you see here, which is moving from a digital twin that is built to replicate something, this sort of on the operational side, replicate either an existing system or this system that is disruptive and you've imagined it. You build a digital twin and then you simulate its use, or you use IoT technology to estimate its real use and get feedback on its real actual consumption and use. And that feedback helps you then redesign your assets or rethink those assets. And the data that is basically moving between the real world and the virtual world is what allows you to continually optimize the use of these different systems, be it power supply, the building industry, industrial manufacturing systems, transportation systems, agricultural systems. So if you imagine, you can use these constant feedback loops, first of all, to optimize your design before you've put it on the market, but then also when it's on the market, use IoT technology and sensor technology to be getting constant feedback and doing predictive maintenance and be redesigning your systems in real time as needed. That type of constant feedback loop is what we mean when we say get your design right, and get it right to a level of extreme accuracy that's really data driven and sustainability driven in this case. So this is another take about the same topic, which is not only are these technologies applicable across different industries and different sectors of the economy, but also within a company's operations, you can use the virtual twin to optimize for sustainability in every single stage. So research and development, you obviously have at the molecular level, you can design new materials, new biomaterials, or materials that will biodegrade faster, that will be lighter, and so have less carbon impact in terms of transportation, et cetera. So at that level, it's the impact is very, very clear, and we do a lot of work at the molecular level and material science level. Design and engineering, same thing. So generative design, so getting feedback loops that basically say, how can I design in a more sustainable way? What do I need to change in my prototyping to be able to cut this carbon footprint in half? So what would I need to change in its design, in the materials I'm using, in the way it's constructed? How can I work on that? Then you get to the manufacturing phase. So how can I optimize the way I either build my factories, or again, how do I use the feedback loops from sensor technology, et cetera, to optimize those manufacturing operations with sustainability in mind. Transport and logistics. So if I want to take this product I've made and I have manufactured and get it somewhere, you can of course now optimize for the best route. That used to be just about the fastest route, but now of course we're talking about the lowest carbon routes as well. And you can see, you know, at an individual level, you have you know, Google Maps allowing you to do this now as well. But at a large scale industrial level, when you're talking about very complex supply chains, this kind of technology can help you solve that puzzle for the lowest carbon footprint. Product and asset use, again, this is about feedback loops and getting the information on what is the actual emissions level or water consumption level or what have you from what you've designed, and does that match with what you thought it would be, and how can you adjust that? All the way to decommissioning and end of life. So a lot of this has to do with design for recycling, design for dismantling, and design for decommissioning. So when you no longer are using either a product or a manufacturing plant, et cetera, how is it going to be dismantled? Where are those materials going to go? How can they be reused, recycled, recuperated? And that is really this vision of the circular economy. You are able to model that in a virtual universe in a way that makes you get it right from the beginning, instead of trying to deal with that post facto, which is almost impossible to do, as we know. So our conviction about this is really that virtual universes will be a key enabler for our customers, but actually for the world, to imagine, design, and test the radically new products, materials, and manufacturing processes of tomorrow's sustainable economy at the fastest possible speed. And we like to underline that speed component because we are in the decade to deliver. And if you think about how can I completely rethink the products I put on the market, the packaging I'm using for them, the manufacturing systems behind them. These are not things you can fix in 1 year or 2 years or 3 years or the 10 years we have available for us. And you definitely can't fix them if you can't experiment and do all of the experimentation phase in a virtual form before spending 10 years to try something new. We don't have 10 years left to try something new and find out it's wrong and it won't work. We need to do that virtually and get those new designs and new products and new manufacturing systems on the market as soon as possible. So this was the sort of quantitative side of the case study that we did with Accenture that I mentioned earlier, and sort of how you can summarize that potential by taking some real use cases. So we looked at constructions in cities, where we were looking at energy consumption in buildings and how do you reduce energy consumption in buildings, often through these feedback loops. Consumer packaged goods, so eco-designing products, packaged goods from the beginning will reduce 80% of their impact. If you try to footprint it after it's already built, that's very nice for reporting purposes, and people like me need that data to report to the outside world, but it doesn't help you reduce the impact. You need to do that before you have built the product, and that's what virtual twins can help you do. Transportation and mobility, accelerate the time to market for the next generation of mobility solutions. Again, most electric cars in the world are built with this technology, and that's what allowed that type of breakthrough in sustainable mobility. Life sciences, so something you all know about very well. It's possible to reduce waste, pollution, and resource consumption in pharmaceutical manufacturing, thanks to this the version of the virtual twin where you're looking at the full operations and the full manufacturing system and how you can optimize that for resource consumption reduction. And the last use case we looked at with Accenture was high tech, so electronics and embedding circular economy principles to address the growing problem of e-waste. So again, designing for recyclability or dismantling. And then the quality of the materials being used. So all of these use cases, we took 5 use cases, and we said, if those 5 use cases were expanded and were, the use of virtual twins was generalized across the world to address all of those 5 use cases, what would the impact be? And basically we came to the conclusion that you would have 1.2 trillion of economic value. So that's a lot to do with just, I didn't waste 10 years trying something that didn't work. I got it right the first time. And I was able to, in doing that, in optimizing for sustainability, reduce resources and improve efficiency at the same time. So that's the economic value. And on the global sustainability side, we took CO2 as the indicator, 7.5 gigatons of CO2 reduced through these projects. You see just those 5 use cases extended globally by 2030 would have that kind of impact. And just to put that in perspective, that is the global footprint today of the transportation sector in terms of CO2. So massive impact if we are thinking about our systems and testing them and simulating them and optimizing for sustainability, thanks to virtual twins from the beginning. And not just trying to footprint and report on carbon post facto, but from the beginning, understand what that impact's going to be before you put any product on the market or before you start a new manufacturing process. And so that is what we are excited about, what I'm happy to share with you today. If there are questions or feedback, please reach out to us. Would love to engage in a conversation about this. We are really convinced that this technology is a game changer for this decade to deliver. Thank you for your time.
Okay, thank you very much, Alice. That was very inspiring, very insightful, and also very, I'd say, very interesting, because those figures that you just ended your presentation with are quite huge figures. And just like you mentioned, this is the decade of change. We need to, there has to be a change now. What in your what would you say is the biggest barrier or key barrier to actually adopt these kind of technologies?
That's a great question. And that's something that we actually looked at with Accenture. So in addition to the use cases and the quantification, there was a part of this study which I invite you all to read online. It's on the 3ds.com website. But we actually did interviews with different industry leaders and said, what do you think the challenge is? Look at this amazing potential. What do you think is stopping the world from using these virtual twins more often? And I think the main sort of takeaways, there are a few, but I'll just cite a couple. One is the fact that, and this applies to all technology, is that today, whilst I mentioned that the global agendas in terms of tech and sustainability are really merging, like those are seen as very common. There's a lot of overlap in those global agendas. At the company level, within companies, there's still not a lot of connection. So you have tech budgets on one side, you have a bunch of sustainability work being done on the other. Sometimes you have communication between those departments, but there's not an alignment in terms of tech investment to meet the needs of sustainability and vice versa. So I think the combining of those two agendas was one of the key issues. I think there are some barriers to entry in the sense that these are very sophisticated technologies. So if the company itself is not pretty far along on its own digital journey, this is quite a sophisticated digital technology. And so you do need to have already, your data systems all need to be already digitalized to feed them into these types of systems. So that, I think, is a barrier. So if you're really just starting your digital journey, it's hard to make this jump because you need a bunch of digital information to feed into it. And then the last one, I think, is sort of has to do with the amount of kind of collaboration needed. So one of the wonderful things about the Dassault Systems platform is that it allows, like, for example, when you're building a car, you could have 3,000 people in a company working on a model, a new model of a car. What the platform does is it allows everybody to see where you are in the design, and they see physically, because it's a 3D model, exactly where the design is, and all the people are working on the same version in a way that you just can't do without digital collaboration tools like that. And so it's sort of like Google Docs where everybody can work on it, except you're building a car. So it's a 3D model. And you can say the same thing for a new pharmaceutical manufacturing plant. And that level of collaboration is enabled by the digital twin technology, but it's not always easy from an organizational and a human perspective. So a lot of companies are still very siloed, and their people are working in very different functions and very vertically. And so getting people to sort of work together on a project in a very connected way is not something that's instinctive in all organizational cultures. So that's actually, often it's not a tech problem. This is the same we say for climate change. It's actually not a technological problem or a scientific problem. It's a human problem.
I see. Well, yeah, I can imagine. We're of course a Dassault system partner, so we do help companies with implementing the 3D experience platform, and we of course we do see the challenges of actually getting people to actually collaborate more and getting the different departments to collaborating more in order to remove those barriers of siloed way of working. So yeah, thanks very much. I think we're running out of time, actually. I would love to have a longer conversation with you. But again, thanks very much for sharing your insights, your knowledge, and thanks for being on stage.
Thank you, Rehan. Thanks to everyone for listening. Thanks very much.